And it's a bit of a generalization, I guess. Areas under the curve. And I have, of course, right there on the handout, I have just so happened to have a curve, actually 4 of the same curve, but you'll see why in a minute. And we are just going to call that some f of x there. So our function, labeled there in blue, is f of x. And we are going to try to find the area under the curve, and it's going to be between certain values. And to start off with anyway, we're going to try to find the area under the curve for this one from x equals 0 to 9. Like I was saying, area under the curve it's kind of a simplification of what it is we're really trying to find, because if I say find the area under the curve, if you go out down to infinity, negative infinity, that would be impossible to do. But what we actually really mean by that, area under the curve, is just a nice way to put it. And then there's some other times when it's really not even under. But that's just a nice way of putting what I'm trying to find is the area between the curve and the x-axis. That's what I'm seeking. Area between the curve and the x-axis. Well, because of its curved shape, what we're going to start off with anyway is just kind of estimating this with rectangles. And in this case, we're going to estimate this area using 3 rectangles and what we call right endpoints. 3 rectangles and right-hand endpoints. Here's what that means. Well, first of all, what that means is right endpoints. Let me finish my writing before I move on here. First of all, what that means, and I, of course, chose 3 because how many units am I talking about? From 0 to 9, that's 9 units there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So, yeah, this is going to divide up very nicely into how many width-wise, how many units will be the width of each rectangle if I'm using 3 rectangles. Again, I'm also point out when I say 3 rectangles, I mean 3 of the same size rectangles, and so uniformly wide anyway. And so, yes, since I'm wanting 3 rectangles and it's 9 units long, this is going to divide up nicely into 3s, right? The width of each rectangle is going to be 3. I'm going to come out here to 3, and then I'm going to come out here to 6, and then I'm going to come out here to 9. And that's going to be the width of my rectangles. Now, the height of my rectangles, well, that's where the function comes in, and the right-hand endpoints comes in, because what that means is I'm going to come over here to the right, and I'm going to go up until I hit the curve. And then that's going to be the height of my rectangle. So I'm going to square that off. Then at 6, I'm going to do the same thing, since it's the right-hand endpoint of that one. And do the same thing for 9, all right? Everybody okay with me on that? All right, well, in this case, since I don't know the function, I'm just going to use estimates here. Of course, the first, so the area under the curve is going to be approximately equal to then the area of each of those rectangles, which the first rectangle is a 3 by what? Well, that's like I'm saying, I'm going to estimate 1.5. Is that the value right there? 1.5, thereabouts. Sounds good. Okay. And then the second rectangle, well, it's 3 times whatever height it is, which mine looks like it's just above 3, so 3.1, 3.1, 3.2, something like that. And then the third rectangle is a 3 by, is it right at 6? Yeah. Okay. So the area under that curve is roughly, very roughly, of course, what that equals. It's 4.5, was it 4.5, 9.3, and 18. What does that give me? Something 0.8. 27, 31.8. Does that sound right? Okay. About 30, about 31.8. Now, of course, if I'm talking the actual area under the curve, is that it's going to be more or less than 31.8. Obviously, the area under the curve is actually a little bit less than 31.8, isn't it? Because these rectangles have some extra extra area. But anyway, we're just getting a rough area to start with anyway. So let's, one other bit of notation here. Because on the next one I'm going to use left-hand endpoints for various and for other various reasons. What we're going to call this estimate right here, we're going to call it R3. Any ideas why? Right-hand endpoints, 3 rectangles, okay? So let's approximate the area again for this very same curve, 0 to 9. Using L3. What do you think L3 means? Well, L3 would be 3 rectangles, but left-hand endpoints. And so I'm still going to divide it up into 3 rectangles, so I'm still going to break it up into we call them sub-intervals. The interval is 0 to 9. Sub-intervals, then we're going to go by 3s here, 3, 6, 9. However, my heights, I'm not going to come to the right-hand endpoint of each sub-interval. I'm going to start here at the left-hand endpoint. So you see here, this first one, the height would be at this, the left-hand endpoint of that sub-interval is right here, which is right at 1, isn't it? What about the height of the second rectangle? Well, the height of the second rectangle, which is going from 3 to 6, the second sub-interval then would start here at 3. Whatever height that gives me, which is not quite up there to 2. And then the third sub-interval, we're using the left-hand endpoint of it, so I would come here at 6. Okay? All right. So what does that give me? Well, it gives me a 3 by 1 for the first one. A 3 by, what do we call it, 1.5 for the second one, and then a 3 by 3, 3.1 I think is what we had. It's a little above 3, so something like that. So we got 3, L3 would be 3, 4.5, and 9.3. So that is also 0.8, 16.8. Quite a bit of difference between L3 and R3, but you can see why. What about L3 there? Is that an overestimate or underestimate of my area under the curve? That'd be a little bit of an underestimate, wouldn't it? Quite a bit of an underestimate because, yeah, when I'm talking the area under the curve, I'm talking, this whole area here. And so I've got these little pieces that, I could figure out what those are, but that's not really the point of this. But yeah, so I've got a little bit more area under the curve than that represents. So lots of ways you can get better estimates. Of course, one thing we could do is just kind of average those two. But here's another better way. Let's do M3. let's use get this area under the curve using M3. Any thoughts what that might be? Midpoints, yes. So this is M3 represents using midpoints. 3 rectangles, but using midpoints. So again, I'm going from 0 to 9, but I'm going to use midpoints. So again, from 0 to 9. So 0, 3, 6, 9 are my breakup of my subintervals. But if I go at the midpoints, here's what happens. Now, between 0 and 3, the midpoint would be where? 1.5, wouldn't it? So my height, you see, is like that. Because I come at the height of my function there, and that's going to determine the height of my rectangle. Then I come over here at where would the next one be? Well, if you'll notice here, I did that one at 1.5, or tried to. It looks a little bit off from where it was supposed to be. It's supposed to be right there. The next one is at 4.5, because just add 3 to that 1.5. So if I come up at 4.5, it gets me somewhere around there. So my height of my rectangle is that. And then what would be the next one? 7.5. So come up in the middle, 7.5, and that gives me. And you can see why that would be a better estimate, because why? Well, you got some give and take, right? We've got this piece right here that's more than the outside the curve, if you will, above the curve, but then we've got this piece, which right here, which is not being counted. Same thing all the way down. So you've got some give and take, if you will. So anyway, it works out better. Better estimate. So the midpoint M3 estimate would be what? Well, again, they're all 3s, so it's a 3 by 1.2. Your estimate might be a little different. The second one is a 3 by 2.3, I'm going to say. And then the third one is a 3 by, it's right at 4.5 to me. So that's 3.6 and 6.9 and 13.5. So I get it to be 24. I do the adding right of my numbers. 3.6, 6.9, and 13.5. So it's right? Okay. All right. Okay, so yeah, that would, out of those 3, yeah, that's probably going to be your best estimate of those 3. Of course, other ways, even we could improve upon that. What are some other ways we could improve on that? Well, we could get more and more rectangles. Instead of doing 3 rectangles, we could do 9 rectangles. That would mean the gap that it's off is smaller, because your intervals are smaller, your subintervals are smaller. So you get more and more rectangles, and that's kind of the idea that where we're going with this. But let's talk one more here, just get a few other things. Let's change it up. Let's estimate the area under the curve on this fourth one from x equals 1 to x equals 8. Using R5. So I've changed it up. We're not going from 0 to 9 now. We're just going 1 to 8. And we're using R5. 5 rectangles, right-hand endpoints. Okay, so first of all, the width, let's talk about that. The width of my rectangles for R5, what is it going to be? Well, each rectangle, if we want uniform rectangles, each rectangle, it's not as nice as the other one where we could just say, well, it's got to be 3. Yeah, here we've got, what, we've got 7 units to cover, and we want 5 rectangles. So here's the thing. To get the width, if you ever in doubt, just take the endpoints and subtract them, and then divide by the number of rectangles you want. Right? That'll give you 7/5 or 1.2. This is called what we refer to as the width will be what we call as delta x. The change in x, we've used that before. 1.4, thank you. Just checking, y'all. The eraser's harder to find than just scratching it out. All right, 1.4, thank you. That is also, that will also be referred to as delta x. We've mentioned delta x before, but it'll come up a little bit more in our discussion as we go along here. Okay? Now, what that means is then if I start at 1, where's the next endpoint, if you will? Well, 1.4 more. 1.4 added to that would be what, 2.4? And then 1.4 added to that, let's go ahead and mark the rest of them. 3.8. 3.8, 1.4 added to that, is that 5.2? And then 1.4 added to that, 6.6. And then that'll get us to the 8, the next one. So that's 5, isn't it? 1, 2, 3, 4, 5. Yeah. So it is 5 units there. So let's see about R5. So what does the first rectangle look like? Well, the first rectangle looks like what level do I go to? Well, it's R5, so I go to the right-hand endpoint, right? For my level, it'll be right there. So that first rectangle is about that that tall right there. Okay? The second one, well, coming here at 2.4. No, that was the second one. Oops, I got off a little bit. 1.2, 2.4. Okay? Can't read my own writing there. All right, 3.8. Come to that right-hand endpoint, so it's right there. Then I come up at 5.2. So it's not quite as nice looking as the others. They're not right on the marks, but this is what I see. And so that's going to give me, again, an overestimate for this particular graph. The right-hand endpoints won't always be overestimates, by the way. It just depends on the curve that you have. Actually, concavity has a lot to do with it. But anyway, R5 would then be 1.4. Let me just also show you here. You can do 1.4 times all of them, but 1.4 is going to be a factor in all those, isn't it? So I could just say 1.4 times add up all the heights. You with me on that? Okay. All right, so it'd be 1.4. That first height looks to be about, I'm going to call it 1.5. That second height is, well, at 3.8. I think it's, let's just say right at 2. And then the third one is right there, so it's 2.8. The fourth one should be right about there, so let's call that 3.8. And then the fifth one, that's right at 5. So it could just say 1.4 times the sum. So I don't have to multiply as many, just add all those up, and then multiply all at once by. So I get 1.52, plus 2. 15.1. 1.52, 2.8, 3.85. I'm getting 15.1.